Welcome to our newest unit, which is going to be over quadrilaterals. This is the video for 6.1 notes, which is going to talk about the polygon angle sum theory. Since we just wrapped up with circles, now it's starting to work on polygons, meaning, many-sided shapes, because we focused a lot on triangles in the past. So a polygon, the technical definition that we're going to use, it is a plane closed shape So a plane closed shape with straight sides. Okay, so meaning plane, this spelling of plane means like a coordinate plane, which means that it's two-dimensional. Closed, meaning that there should be no spaces or gaps in the shape, or at least around the edge of the shape. And straight sides, there should be no curves, no squiggles, anything like that. Everything should be perfectly straight lines. So the first few problems that we have here, we're just kind of stating whether the figure is a polygon or not to better understand the definition. Okay, so number one, if I take a look at this figure, it is two-dimensional, right? It is closed. I don't see any gaps or spots in it. And it does have straight sides. Nothing is curved. So yes, this would be a polygon. Okay. Now, when I look at number two, it is closed. It is two-dimensional. But if you look for the straight sides, if you notice the corners here, each of these corners are curved. Okay, so therefore, just because those are curved, it cannot be a polygon. So that one is a no. Okay, number three, it is two-dimensional. It is closed. But again, if you look for straight sides, there's these curves right here, this bend in the shape. We don't want that. That cannot be a polygon. Number four. Okay, so when you look at number four, it is two-dimensional. It is closed. You don't see any openings or gaps in the shape. And then if I look for straight sides, it looks like everything is straight here. So yes, this would be a polygon. Okay. And lastly, number five, this is two-dimensional. It does have straight sides, but if you notice right here, it looks like there is like a hole in the shape or a gap of some sort. That's not closed, so no, this cannot be a polygon. Okay, so hopefully those few examples kind of clarify like what is and what isn't a polygon. For the next thing that we're going to talk about, we have to talk about concave and convex shapes. Okay, so the definition that we're going to use for concave, like typically you think of the term or hear the word like cave, you think of like a cave in, right? So we're looking for something that's kind of caving in on itself. Basically, at least one angle or at least one interior angle. Oh, whoops. Angle is 180 degrees. Okay, so think cave in, like it's pointing inwards. The sides are going to point inwards, and that's going to indicate that one of the angles is greater than 180. Okay, now convex is the opposite of that. All angles are less than 180, or all interior angles. So you're looking on the inside of the shape and not on the outside. Okay, and that's convex. Most of our shapes that we focus on are convex shapes, but it's better to understand the difference here. So if I look at number 6 and I look at all the angles inside number 6, okay, it doesn't look like any of them would be greater than 180 degrees. They all look smaller than that. So this would be considered a convex shape. Okay, none of the sides look like they're pointing towards the center of the shape. But number 7, if you take a look, so kind of following the angles around these two angles right here. Okay, if you notice, the sides kind of point inwards, in towards the center of the shape. But those angles, if you were to measure them, they would be greater than 180 degrees. So this is what we consider a concave shape. Number 8, if we're trying to tell if it's convex or concave. So again, if any sides kind of point towards the inside of the shape, it's probably concave. So I have these two right here. And if I look at those angles, yeah, those angles are definitely greater than 180 degrees. So this is concave. For number 9, okay, it doesn't look like anything's pointing towards the middle of the shape. And if I were to measure each of these angles, none of them would be greater than 180. So this is convex. And lastly, number 10, okay, so a star, there's actually multiple angles here. There's 5 total angles, or 5 points that kind of point to the inside of the shape. So this is a concave shape. Okay, and hopefully those examples kind of help with the difference in those two terms. But if you need more or you have any questions, please let me know. All right, the next thing we're going to do, I'm actually going to zoom out a little bit here just to try to get the whole table on. So we're going to take a look at some basic polygons and kind of talk about, side lengths and diagonals and different names and things and what all of it means together. Okay, so the first one, if you notice, it's a 4-sided shape. So if you want to list, it has 4 sides. Typically, I usually hear 4-sided shapes called one of 2 names. A lot of times I hear the word rectangle, or a lot of times I hear the word square. Okay, not all 4-sided shapes are rectangles or squares. Those are special, and we'll talk about those in a different lesson. But when it comes to 4-sided shapes, their technical name is a quadrilateral. Okay, which will be the main focus of this chapter, but just so we're aware, that is the technical name. Okay, so the next thing that we're going to do after we name it and talk about the number of sides, we're going to draw in diagonals in this shape. And all the diagonals that we draw are going to come from the corner labeled A. Okay, so if you notice, each shape has a corner that's labeled A. If I were to draw in a diagonal, remember, you're connecting this corner to other corners in the shape that aren't connected by a side. Okay, so the only one I can actually draw in here goes from the top left corner to the bottom right corner. That is one diagonal. If I try to draw the other 2 diagonals or connect to the other 2 corners, that's following a side, and those don't count. All right, so the reason we're going to draw in these diagonals, we want to look and see how many triangles end up in the picture. So if I, connect the top left to the bottom right corner, there ends up being 2 triangles in a quadrilateral. And here's what we want to think about or work on. Okay, so every polygon has a different number of degrees on the inside. Like triangles, we know, have 180 degrees. Okay, now circles aren't polygons, but we just learned about circles, and they have 360 degrees in them. So each of these shapes will have a different number or total number of degrees to work with. And here's how we're going to kind of think about it at first. Well, if I have 2 triangles in this shape, I should be able to take 180 times 2, because there are 2 triangles, to get that total number of degrees. And for this, it would be 360. Okay, so in a quadrilateral, any 4-sided shape, they're all going to have 360 degrees as their total. Okay, the next shape that we have, so if you count the number of sides, there are 5 sides. And hopefully you've seen this type of shape before. As far as naming the shape, there's actually a pretty famous building that is named this in Washington, D.C. All 5-sided shapes are called pentagons. Okay, so a pentagon is a 5-sided shape. If I were to draw in its diagonal, so I'm using this far left corner here, I can only connect it to 2. I can connect it to the top right and to the bottom right. Okay, so I can only draw in 2 diagonals without, following a side. Okay, so that means if I draw in those two, that's going to split my pentagon into 3 triangles. All right, so if I want to find the total number of degrees here, I could take 180 if there's triangles involved, and there are 3 of them, so I'll multiply by 3, and I'm going to end up with 540 degrees. Okay, so all pentagons have 540 degrees on the inside. For the next shape, so if you count the number of sides, there are 6 sides to this shape, and all 6-sided shapes are called hexagons. Okay, so hexagon, you probably see them if you've seen like, bees make honeycombs, like they're the hexagon shape. And if I were to connect my far left point to opposite points here to create diagonals, I can draw in 1, 2, 3 diagonals. And when I draw those 3 diagonals in, if you notice, I end up creating 4 triangles. Okay, so 4 triangles are here, which means if I take 180 and times it by 4, I should get the total number of degrees in a hexagon, which is 720 degrees. For the next polygon, so if you count the number of sides, there are 7 sides here. This name's usually a little less familiar to us, but a 7-sided shape is called a heptagon. So almost like hexagon, but with a PT instead of an X. And if I were to connect this point to opposite points with diagonals, I could draw in 1, 2, 3, 4 diagonals. So we have 4 diagonals there, which creates 1, 2, 3, 4, 5 triangles. And that means to find the number of degrees, I can take 180, multiply by 5, and that's going to equal 900 degrees. So those are for our heptagons. Okay. The last shape that we have, okay, if we take a look at this shape and you count the number of sides, there are 8 sides here. And 8 sides, usually we're familiar with this term, it's an octagon. Okay, an octagon, like octopus, right? They have 8 legs, so this has 8 sides. And if I were to connect the corner that's labeled A to its opposites, I can connect 1, 2, 3, 4, 5. Okay, so there are 5 diagonals drawn in. They're not the prettiest of diagonals, but they are there. And it should create 6 triangles for us. There are 6 triangles in this figure now. Okay, and if I take 180 times it by 6, I'll get the total number of degrees in every octagon, which is 1,080 degrees. So 1,080 for octagons. All right, now that this table is built, you can use it anytime that you want. But here's something to consider. Like, there are an infinite number of polygons because you can create a shape with however many sides you want it to have. So here's what you can consider or think about. Up to a certain point, we don't really name them anymore. But let's say we wanted to find the number of degrees in some other type of polygon. Hopefully, as you've gone through and filled in this table, you've noticed a pattern, okay? If you take a look at the number of sides for each of these polygons and the number of triangles, okay, the numbers or the pattern that you should have noticed is that the number of triangles is always 2 less than the number of sides. So like looking at our heptagon, well, there were 5 triangles with 7 sides. For the hexagon, there's 4 triangles with 6 sides. So it's always a difference of 2. Okay, so if you notice that pattern, we can put that together, and there's actually something called the interior angle theorem, or the sum of the interior angles of a polygon, can always be found with this little formula. So you could take 180, the number of, or all the degrees in a triangle, and multiply it by n minus 2, okay, where n is the number of sides of the shape. Okay, if you know the number of the sides of any shape, you should be able to plug that in for n, subtract 2, multiply 180, and that'll get your total number of degrees. Okay, and that's actually what these first few examples are working on. So in number 9, it says, what's the sum of a nonagon? So I know we didn't necessarily talk about nonagon, but nona means 9 sides. Okay, if you're ever not sure about one of those, you could always just Google it, right? Like how many sides does, how many sides does a nonagon have? If I want to find the total number of degrees on the inside, though, I could take 180, multiply it by n. Well, I'm plugging in 9 for n, 9 minus 2, and then I just work on simplifying. So 180 times 9 minus 2 is 7, and 180 times 7 gives me 1,260. Okay, so that's the total number of degrees in any nonagon or 9-sided shape. All right. So number 10 is similar. What is the sum of the degrees in a 102-agon? Okay, so at some point, we kind of run out of names for all of these shapes. So they just kind of use the number to describe the number of sides. Okay, so that means this 102 is going to be n. If I want to find the sum of the degrees, I just need to take 180, times it by 102, 102 minus 2, and then simplify. So 102 minus 2, that leaves us with 100. And if I take 180 times 100, I'm going to get 18,000. So any shape that has 102 sides, which you got to think that's a lot of sides for a shape, it's going to have 18,000 degrees on the inside, which is also a lot of degrees. Alrighty, so the next few examples are kind of taking this information a step further. If you can pinpoint what kind of shape it is and how many total degrees there should be, can you find missing angles? Okay, that's what we're going to work on in the next few examples. So in number 11, it says to find the value of x. So first, count up the number of sides. Okay, well, this is a 4-sided shape, which is a quadrilateral. And according to our table, if you go back, 4-sided shapes or quadrilaterals all have 360 degrees as their total. Okay, so if I take a look here, it looks like they gave me 3 of my 4 angles. I just have to find the 4th one. So if I were to combine 112 plus 71 plus 48 plus x, all of those would have to add up to 360. Well, if I write it out like this just turns into an algebra problem, right? So I can combine 112 plus 71 plus 48. That was going to be, let's see here. It's going to be 231 plus x equals 360. And then if we want to solve for x, all we would have to do is subtract the 231 from the 360, and we should be able to find x. So when we do subtract, we will be left with 129. So the missing angle we had to find was 129 degrees. Okay. All right, so number 12. Very similar process here. The only difference is if you notice the number of sides of this shape, this is a pentagon. It has 5 sides. And according to our chart, all the 5-sided shapes, pentagons, have 540 degrees. So we need to add these angles up and set it equal to 540. So we can do 124 plus 100 plus 100 plus 118 plus x. Set that equal to 540. Okay, when we do that, if I go to combine all the numbers that I have, so 124 plus 100 plus 100 plus 118, we'll be left with 442 plus x equals 540. Okay, and then we need to subtract the 442 to the other side. Okay, so x would equal 98 degrees. All right, so those are the steps that we're going to take in order to find missing angles. In the next few examples, we're looking at these 2 shapes we're just going to do 13 and 14, 15 and 16. You can practice on your own. But here's the thing. Since we're going to set them up like equations, we're not necessarily given every whole angle. We're just given terms for each angle. So kind of think about that when you go through. And number 13, okay, well, if I check, it's a four-sided shape, which means 360 is the total. So we need to combine our angles together. So we're going to add 50 plus 70 plus 7x plus 5x, and that's going to equal 360. Okay, now if I go to combine like terms, 50 plus 70, that would simplify to 120, plus 7x plus 5x becomes 12x. Okay, and now it's a little bit more of an algebra problem to solve. If we want to solve for x, we subtract the 120 from both sides. 12x would equal to 40. And then we would have to divide by 12 to get the x by itself. X in this case would have to equal 20. If you notice, since x isn't a full angle, it's just a part of an angle. I didn't label it with a degree symbol, but you can. It's okay. All right, and the last example that we're going to do together, we're going to take a look at 14. So another four-sided shape, meaning the total is 360. If I were to combine these angles together, I would have 118 plus 72 plus, now keep in mind, 3x plus 10 is a whole angle. You need to put both terms down, 3x plus 10. You don't have to put the parentheses, though, because we're adding all these angles together, just so you know. And then we need to add on the 5x and set that equal to 360. Okay, and then we need to combine like terms. So we can combine the 118, the 72, and the 10. If I add those three numbers together, I should get 200. Okay. If I combine my x's, I have 3x and 5x. If I add those, they would become 8x. Since we are solving for x, we would want to subtract the 200 from both sides. 8x will equal 160. And then divide both sides by 8 to get that x by itself. And when we find x, it would also equal 20. So obviously it won't work like that every time. It just happened for those two problems. But hopefully those kind of explain what to do with our angles and our polygons and how to solve some problems there. Okay, if you have any questions about that, please let me know.